Okay, so this is the reteach for sample space and simple events from the probability test that you had. These are numbers 1 through 7. If you are looking for the second part, which is 8 through 14, that's going to be in another video called compound events. So make sure you're doing the correct reteach, so you'll be able to get a better grade on that. Now remember, you do need to have a test corrections page. Remember, you do have to have your test, and you are only writing down all the work and showing your answer and the correct answer from your test. Make sure that you are explaining what your mistakes were. Make sure that you are stopping the video after each question. That way you have a chance to go ahead and do the explanations. So make sure you get your paper ready. So here's number 1. And number 1, it has to do with sample space. So what we're going to do, we're going to go ahead and read the question. And I'm going to explain to you how you could tell what the event was. So the tree diagram shows all the possible outcomes for which event. So if you look at that, you have heads and tails. Then you have heads, tails, heads, tails. Then you have heads, tails, heads, tails, heads, tails, and head, tails. So basically, when you flip a coin, this is one coin. So the first part is one coin. The second part would be the next coin, or the next, actually, the next flip. It doesn't have to be different coins, it just needs to be the different flipping of the coin. And then the last section would be the third coin. So if you notice, just looking at the way it's designed, then you could actually go ahead and do this as 3 coins. So that means this sample space represents a coin tossed 3 times. Now, if you look at this, it could also be horizontally. So this was horizontally, the one they showed you, but you could also do it vertically, where you have the same thing, and you would show the same way like I did, showing each of those sections. So let me show you. Let me do this. So in this case, the first part would be 1 coin. The next part is another coin. And then the last part is your third coin, or your third toss. It doesn't have to be different coins. Like I said, it could be just different tosses. So make sure you stop the video so you could explain what your mistake was. Number 2. Bailey will roll a number cube and flip a coin for a probability experiment. The faces of the number cube are labeled 1 through 6. The coin can land on heads or tails. If Bailey rolls the number cube once and flips the coin once, which list contains only the outcomes in which the number cube lands on a number greater than 4? So we know the probability for a coin is going to be 2, which is heads or tails. Okay, for the number cube, basically, that's going to be 1 through 6. Now it's asking for the number cube to be greater than 4. So I know 1 is not greater than 4. 2 is not greater than 4, 3 is not greater than 4, and 4 is not greater than 4. So the only 2 outcomes would be 5 and 6. So we're looking for the cube to be 5 or 6, and then the coin to be heads or tails. So in this case, your answer would be letter A, because it has 5 or 6. C is not your answer because 5 is missing tails and 6 is missing heads. B, well, it's including all the numbers, so that's wrong. And D, it includes 4, and 4 is not greater than 4. So make sure you understand the difference between showing a sample space of everything, which would be letter B, and then a sample space with certain conditions. Again, stop the video so you could explain your mistakes. Number 3, Sarah's making a card. She has a drawer with 3 red, 2 pink, 5 green, 1 white, and 4 purple pieces of paper. How likely is that Sarah will randomly select a pink piece of paper? So in this case, we're looking for the probability of pink. Okay, so when you look at it, we have to add up the totals. So we have 3 plus 2 is 5, plus 5 is 10, plus 1 is 11, plus 4 is going to be 15. So we have 2 pink out of 15. So remember, anything less than half is going to be unlikely. Anything more than half is going to be likely. And if it's right in the middle, it's equally likely. So then what we're going to do is we're going to go ahead and look to see where 215 lands. So I know half of 15 is about 7.5. So if it's less than half, then that means it's going to be unlikely. So we have this as unlikely. Go ahead and stop the video so you could do your explanation of your mistakes. Number 4. Felix has a bucket of golf balls. The table shows the number of golf balls of each color in the bucket. Felix selects a golf ball at random. So we're going to first total them because we need to find out what this would be. So we have 4 plus 11, that's 15, plus 8 is 23, plus 18 is 40, 51. 41. 20, 36, yeah, 41. So this is 41. Okay, so based on the information, what statement is true? The golf ball is more likely to be green than any other colors. So golf ball is green, that's going to be 18 out of 41. So that means, and then all the other colors will be, that's 19, 20, 23. So golf ball is more likely to be green than all other colors combined. So is this true? Maybe, maybe not. Let's go on with the next one. The next one is saying the golf balls is equally likely to be pink, white, green, orange, or green. Well, the only way this would be is that all the colors have the same number of golf balls. So that's why it would be equally likely. So then we know B is wrong. C, the golf balls is 2 times as likely to be orange as it is to be pink. So orange is 8 out of 41. Pink is 4 out of 41. So is orange 2 times as likely as pink? Could be. So let's go ahead and just keep that blank. And let's do the last one. The golf ball is 7 times as likely to be green as it is to be white. Well, 7 times, we do 11 out of 41. 7 times, that means that you have to multiply that by 7. And if you look at green, green was 18. So I know that 11 times 7 is not 18. So then that would be wrong. So the only answer that will be correct would be letter C. Number 5. A dart game at a carnival gives players an equal chance of popping a red, white, blue, or green balloon. The table shows the number of different color balloons that were popped in a dart game at a carnival. So let's go ahead and add this up. So that's 5, 11. 16 plus 4, that's 20. Okay, so here it says, which statement is true? The theoretical probability of hitting a red balloon is less likely than the experimental. So now we're comparing theoretical and experimental. So what we're going to do, we're going to go ahead and look at the theoretical part. Now, theoretical, it only has to do with the number of colors and the probability of those numbers. Experimental is the one where they already did the experiment. So we're going to go ahead and look at that. So when you're looking at theoretical, you're only looking at this part of your table. If you're looking at experimental, you're looking at this part of your table. So in this case, the total would be 4 here. So theoretical is going to be, for red, is going to be 1 out of 4. And experimental for red will be 5 out of 20, which simplifies to 1 out of 4. So it says less likely. Well, isn't that the same thing? So it won't be less likely, it will be equally likely. So we're going to say that is incorrect. Let's look at letter B. The theoretical probability of a white balloon, so white balloon would be 1/4, is greater than the experimental probability, and white would be 6 out of 20. When you simplify that, so we're going to look at it as 3 out of 10. So is 1/4 greater than 3/10? Well, 1/4 as a decimal is 25 hundredths. 3/10 as a decimal is 30 hundredths. So that means this is incorrect because theoretical is not greater than the experimental. Letter C, the theoretical probability of hitting a white ball, so white ball would be 1/4, is less likely than the experimental probability. Experimental would be 6 out of 20. And again, I'm going to change them to decimals. So this is going to be 0.25. This is going to be 0.30. So it says the theoretical is less likely. So this is correct. But we're still going to check the last one. The last one says the theoretical probability of hitting a green balloon, so green is 1/4, is equally likely as the experimental probability. And green is 4 out of 20, which is simplified is 1 out of 5. Well, in this case, it has to be equal, so that means that is incorrect. So D is wrong, so my correct answer will be C. So basically, in each one, you had to find the theoretical probability, experimental probability, and then compare them. So our answer here should be letter C. Again, stop the video and write down what your mistakes were. Number 6. On Roberto's shelves are 6 mystery books, 5 science books, 4 history books, and 3 adventure books. So we're going to add those up. So 6 plus 3 is 9. 9 is 18. So we have 18 books in total. So Roberto would randomly choose one book to read. What is the probability that he will choose an adventure book? So we're trying to look for the probability of adventure. Okay, so in this case, adventure book is 3 out of 18. And that's the probability. All we have to do is simplify it by dividing by 3. So that's going to be 1 out of 6. So my answer is letter D. Stop the video so you could write down your explanation for getting this one incorrect. Okay, number 7. The spinner shown is divided into congruent equal sections that are labeled from 1 through 7. If the spinner spun one time, what is the probability of not landing on a section labeled with odd numbers? So let's look for odd numbers. So there's odd, there's odd, there's odd, there's odd. Okay, so we have probability of odd numbers, would be 4 out of 7. And actually, a lot of you picked A, and that would be incorrect because they're asking for the probability of not odd. And that would be 3 out of 7. So remember, please do not forget the not. When you do that, that means your answer will be incorrect. So make sure that you are looking at that. When you finish up, your probability should equal to 1. So make sure that you have that correct. So my actual answer is letter D. Now, if you were in my class, I did make the mistake of putting A as your correct answer. But then I went back and corrected to make sure that it was D. So go ahead and stop the video so you could go explain your mistakes. Congratulations, you just finished the retest for sample space and simple events probability test. Make sure you ask your teacher for retest so you could better improve your grade. Remember, with this reteach, you only have a 70%. When you take the retest, it actually goes up from a 70. So make sure you turn in your reteach paper with your retest. Turn them into the teacher that you go to the session to, and we'll go ahead and record the new grade when we're done grading them. So good luck on your test, and hope you come back for the other video.